Let's finish section 5.1 by looking at a couple of application problems. There's two main ones that we really run across a lot, and one of them is calculating interest and the amount in a bank account using compound interest. There are two formulas for this, and one of them being A equals P. A is the future value in the account. P is the present value in the account. And then R is the rate or the interest rate. And it's always in decimal form. And N is compounding, how often it compounds. And T is the number of years. So again, P is present value and A is future value. We also have something that's for continuous compounding. Whenever you see in a problem it says it's continuously compounded, you know it is in this form. It is going to be P E to the RT. E is that special number that is a natural number. It's on your calculator, and it will be to the power of the rate, which is the same as what you would see above, and T is in years. So let's look at an example of this. We have $12,000 at an annual interest rate of 3%. Find the balance after 5 years when the interest is compounded. We're going to look at quarterly, monthly, and continuously. So let's look at the first one. Quarterly compounding is just as it sounds. It means it's going to be compounded 4 times a year. In 5 years, you're going to have 3%. So we are going to insert these numbers into this formula. 12,000 is the present value. And notice that 3% was put into decimal form, so it's 0.03. And it is being divided by 4 being compounded 4 times a year. To the NT be 4 times 5 years. So calculating that all out with your calculator, they would have earned, that account would have a total in it of $13,934.21. Let's do the same thing, but now we're doing monthly compounding. And since there are 12 months in a year, your end value now is going to be 12. It's the exact same formula. And if you put it in your calculator, notice that it is now $13,939.40. Lastly, for continuous compounding, we're going to use the APERT. And this time it'll be 12,000 times e to the power of 0.03 times 5. When you calculate that out, you get $13,942.01. Now, you should ask yourself, what is the best value? The more you compound, the better the interest you get. So in this situation where if you look at them, it's going to be the E value, that the continuous compounding. Notice it's 13,942, 13,939. So you made a few more bucks with the higher compounding interest you have. Okay, last example. To begin, a bacteria study in a petri dish had 2,600 bacteria cells. Each hour since, the number of cells have increased by 2.7%. Let T be the number of hours since the start of the study, and let Y be the number of bacteria cells. Write an exponential function showing the relationship between Y and T. So here we are going to have Y. We know our beginning value is going to be 2,600. And anytime something is increasing by a percent, if it's increasing, you're going to always add 1 to that percentage in decimal form. If something is decreasing, you're going to subtract it from 1, and it will be subtraction. So in this situation, it's adding. So I'm going to say 1 plus 0.027. And this is going to be to the power of t, because that is the number of years that in which, or time, in this case it's hours, in which it's compounding or increasing. So this would be our formula for the situation. If something was decreasing, like for instance, if you have a car that's depreciating, say like you bought the car for $5,000, this time you would subtract the amount it's depreciating from 1. So it's going to be 1 minus 0. Let's say it's depreciating by 3% a year. So I'd say 0.03 to the t power. So note the difference. This is a decreasing one. The one on top is an increasing value.